It is really hard to get good MLOps, but with just 5 minutes you can probably get something that makes a very nice prototype or experiment environment for MLOps experiments. So let's go through some of my standard go-to procedures for when doing new MLOps experiments. So first off, we're going to use pyenv to set the Python version. And this is of course so that we easily can swap between different versions of Python and test our experiments. And then we're going to create a virtual environment so that we can keep our dependencies isolated between our projects. Next we're going to install Kedro. Kedro is a framework for getting a unified structure and setting up a basic scaffolding for standard things in MLOps experiment environments. So if we type Kedro new, we can create a new project. I'm going to call this project 2. So what has happened now is that we got a new project directory created. And this directory is already populated with folders for data, configuration files, standard dataset abstractions, and so forth. And we can also we have a CLI thanks to Kedro, which allows us to start IPython notebooks or IPython terminals and do Python notebooks. We can do linting really easily in a unified way that goes exactly the same for all the different projects. Unit testing is already set up. Building documentation from docstrings in the source code. Pinning requirements for libraries and so forth is already set up. So we have a lot of free functionality that I often find myself doing over and over again otherwise. And we also get the unified structure, which means that as soon as I get to a new project, I know exactly what the structure looks like. So the next step is of course to do a git init so that we get version control of our code. And we add this base that Kedro has created for us. So next we need some data to play around with. And I happen to have some data already downloaded, some pictures of cars. So we're going to copy them to one of the data folders. So this is already also a neat feature about Kedro, that it has set up data folders already, so we have the same standard structure on our data between different projects. We can of course change them if we need to, if the project doesn't really adhere to this model, but if possible we try to keep this. So let's copy all the data here. And Kedro also has functionality to understand what data sets there are and use them in pipelines, for example. So we're going to create a config file which tells Kedro where to find the data sets or the data for the data sets. And I'm actually going to copy this from another project. And this is the nice thing about having the same structure on all projects, that it's really easy to copy things if we need to. So in the configuration folder we have two different configs. We have base and we have local. Local is unique to us, or unique to me on my computer, while the base is shared between the developers. So in this case it doesn't really matter since I'm the only one using it. But let's take a look at this config file we just copied. So here we basically define two different data sets. We have one data set called images. This will be our input data set. And it is an image data set with multiple images. It's going to find all images with the suffix .png, which are located in the 01 raw folder in the data directory. And our next data set is masks. It's also a set of multiple images with PNG suffix, but they are located in the 002 folder. So we will need to install some dependencies. First of all, we're going to use DVC for data version control. So let's add that to our requirements list. We also want to have pillow since we're dealing with image data sets. So if we install the requirements. So this is all the requirements for the tooling that Kedro already has set up to us, and the DVC for data version control and pillow for reading and writing images. So this is really a nice environment that we already set up for prototyping. People can spend months building environments, which is basically the same functionality as we get for free here. So let's see, now we have this installed. So the next thing we're going to do is that we're going to add data version control to our data folder. So we initialize a DVC repository right here. And then we do DVC add on data1 raw. So we're going to add this whole folder to data version control. And now we have to remove data1.git git keep. We don't need that one anymore. And so this is since Kedro isn't, Kedro tries to prevent us from checking the data that are in the data folder, but if we use DVC, we want to do that. So because of that, we need to edit the git ignore file. So now we can add data1 to DVC. And we add a DVC file, and we also add the data git ignore file. So if we take a look at the history now, we can see that what we added is a file that tells us the checksum of the 3 different images that we have put in this folder. And what this allows us to do is to use DVC to check that the data is actually as checked into Git. So of course the data is never pushed to Git, just the metadata files provided by DVC. So now we have the data and we want to do something with it. So in Kedro we have something called catalog, and the catalog is the way to abstract data so that we have a unified way of interfacing with the datasets. If we do a catalog list, we can see that we have 2 different datasets, images, which we have put images in, and we have masks, and this will be our output dataset. But we will create this by running a IPython notebook. So let's see. Kedro has already created a notebooks folder for us. So let's just create a new notebook here, and I'm going to call it Find Red Cars, because that's what I'm going to do. So also here we have the catalog variable in our Python environment. And if we list it, we see that we have images datasets. We have mask, which is our output, and we also have a parameter file, which we're not going to use now. But that's also really neat. So that corresponds to a YAML file, which is also in the repository. But we're going to load the images datasets. And here we see the 3 different images we have. Each one gets us a data loader for that. So I'm going to do images equals to, and we create a new dictionary. Loader for key loader in catalog.load images dot items. So what we have now is a dictionary with pillar images. So for example, if we check out the classic one, we have a car. So this is really nice with Kedro, that we don't need to manually read the images if it is an image data set, and manually read the pandas data frame if it is a tabular data set, and so forth. It just abstracts these as classes, and if the right class doesn't exist, we can of course create a new data set. So what we're going to do now is let's find the red things in these images. So I'm going to pip install numpy. Import numpy as numpy, and from pil.image import from array. So we're going to take this pillar image and we're going to create a numpy image of it, or a numpy array. And then we're going to create a mask, a binary mask. So let's do it like images, or the image, numpy image, but just one channel. And then we're going to set a mask where image, where the red channel of the image is larger than 127, we're going to set the mask to 255. And then we create a pillow image from this mask. So now we can see all the red nice parts of this car. But now we actually had a dictionary of different images as our input dataset, and our output dataset should also be a dictionary of images, so that we can make the same transform to each one of the frames that we have put in our input datasets. So let's make a function out of this. Okay, so let's then do a new masks dictionary. Same file name. And for each image we're going to calculate the mask of the image for key image in images.items. Excellent. So now hopefully we can do classic. Yes, there we have our mask. Or we can take a look at the flying cars instead. And here we have our mask for them. So just like Kedro has abstracted how we load the datasets, it has also abstracted how we save datasets. So we had our dataset that was called masks that we want to save to. And we have the dictionary masks that we want to save to that dataset. So now we have saved our data to the dataset. So let's continue that in the background. So now suddenly we have in the O2 intermediate folder we have these 3 images, which are the masks. And we have our IPython notebook for doing that. So first of all, of course, we want to, we should probably go ahead and save that one first. And git add notebooks. So we add that one. And then we want to have version control of our images. Of course, just like before, we should use DVC for that. Just like before, we need to remove, it's already removed from git ignore, so we should probably just be able to DVC add data to intermediate. Okay, so we need to git rm data to intermediate.git keep. So you could probably create a new skeleton for Kedro if you don't want to remove these git keep files all the time, because that is a little bit annoying when working with DVC together with Kedro. But for now we just need to live with that we need to remove those. So now we should be able to do a DVC add. Yes. And we add the DVC file and the notebook file. Experiment to get red cars. Okay, so looking at the Git history now, we have the notebook, and we can see here that we have 3 output files and we can see the hash of them. So if we now, first of all, let's do DVC status, and we see that all data is up to date. If we would do some kind of change here, we can, for example, remove this cell, and we do run all. So we can save. So we can see that the notebook is updated, but we can see on DVC status that the data is the same. So we know that there was no difference in the new data that we saved. And this is actually a really nice way, for example, to do refactorization of algorithms or optimizations. When you constantly optimize the algorithms, you can verify that the results are exactly the same when you run the code after optimization as before. But if we now, for example, would do something like increasing this one to 180, because we had let's show the images again. I think on the flying cars it was a bit too bright on the mask, so we changed it to 180 and we run the cells. So now I have a bit darker image, or let's actually do even 200. Now I have a much darker image. So if we take a look, we still have a changed notebook, and if we do DVC status, we can see that the output data actually changed this time. So if this is such change we want to do, we can do an add on the notebook itself, and we also do DVC So we see the data has changed, and yes, I want to commit it. So now we see that we have an updated DVC file for that data. Didn't I save that one? So it's the execution results. So yeah, we see the new hash for the data. We add all this together and commit it as experiment with lower threshold, higher threshold. So this is probably it for this time. There are a lot more nice features in Kedro. For example, we have all the pipelines that we haven't discussed yet, which are located in the source folder. And what we can do here is that if we want to create a pipeline from a notebook, we can automatically do this from certain cells. So if we add a tag to this notebook, which is called node, the point is that it can make the transition from notebooks to production code really smoothly, because one thing that I commonly see is that you have some experimentation code in a notebook, and then you have some production code in a pipeline, and the synchronization in between them is manual, and it's not always easy to know that it's up to date. And here we can just add the tag to the notebooks that this cell is going to go into a pipeline, and then we can just run a simple command, which we could, for example, add to a Git hook or to a CI/CD system that will automatically create a pipeline based on the notebooks. So there is a lot of nice thing about Kedro. There is a lot of nice thing about DVC. It's really easy to set up this environment, but of course it does not work in all conditions and all situations. So one issue that I find with DVC is that it doesn't really play nice with large files or large data sets, at least not in my experience. If you have a few hundred gigabytes or more in your data sets, then it will take a lot of space on your hard drive, and you have a lot of large cache files. You need to check out a lot of files to check in your data and so forth. So especially if you want to create this automatic data pipelines, or perhaps you want Python APIs to add new data, then DVC is probably not the way to go. For Kedro, it is a bit early in its development phase. There are some things that are not as nice and stable as it could be. And for example, when it comes to video data set, it does not really have a good support. I hope this is something that will be better, and I have a project to create a video data set for it, but I'm not sure that it will be the right tool anyhow. So there are a lot of other tools too that are interesting to use, but that's for another video.